Okay, so this is a revise with me video focusing on cube numbers and the cube root of a number. So if you want to try the questions before I do them, please make sure you've got a pen and paper, and don't forget to pause the video after the new page so that you can try the questions. Okay, starting with question 1. From the list of numbers, write down the cube numbers, and then part B, write down the cube root of 27. Your cube numbers come from multiplying a number by itself and by itself again. So I'm looking for numbers from a very specific list. 1 times 1 times 1 will give me a cube number of 1. 2 times 2 times 2 will give me a cube number of 8. And I need to know these off by heart so that as I see them in the list, I recognise them straight away and I can write them down. 3 times 3 times 3 gives me the cube number of 27. 4 times 4 times 4 gives me the cube number of 64. So I'm not looking at the list, I'm looking for very specific numbers. And I can see that the two cube numbers that they wanted here was the 8 and the 64. The cubed root of 27, well, this comes from thinking backwards now. What did I need to make a 27? And the answer would be 3. Question 2, write down the value of 1 cubed. That's going to be the same as 1 times 1 times 1. 10 cubed, that's going to be the same as 10 times 10 times 10. 10 tens make 100. 100 times another 10 makes 1,000. 5 cubed, 5 times 5 times 5. 5 fives are 25, times by 5 again makes 125. 6 cubed, 6 times 6 makes 36, times by 6 again. Well, 3 sixes are 18, so that's 180. 6 sixes are 36, and put it together. And 8 cubed, so 8 by 8 by 8 again. 8 eights are 64, and then 64 times by 8. 512. Most of the time, the cube numbers that they ask about will be less than 125. So most of the time, we won't need to go higher than 5 cubed. But be prepared to do a bit of mental maths or a bit of multiplication if you need to. So can you spot the cube numbers? Question 3, circle all the cube numbers. 1 times 1 times 1. 2 times 2 times 2 makes 8. That's not in there. 3 times 3 times 3 makes 27. That's not in there. 4 times 4 times 4 makes 64. 5 times 5 times 5 makes 125. 6 times 6 times 6 makes 216. 7 times 7 times 7. Well, we haven't had that one. That makes 343. 8 times 8 times 8. We had that one earlier, that's 512. 9 times 9 times 9. 729, close. And there isn't anything bigger. So here are my cube numbers. And I'm looking specifically in the table for the ones that I want. And there were 3 that I needed to circle. Right, this is talking about the cubed root of 64. This cubed root symbol here means that 64 is the cube number, and I need to work backwards to find out where it came from. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, and so on. But this time I'm given this number and I'm trying to work out where it came from. So for us, what would it need to be so that it could make 64? We're going to be looking for it to be quite small because 5 times 5 times 5 makes 125, so it isn't any bigger than the 5, and it's actually the next one in the list. So the cubed root of 64 would be 4. The cubed root of 8 would come from that 2 times 2 times 2 I just had. And the cubed root of 0 would be 0. The cubed root of 1,000 comes from 10. Okay, if you're allowed to use a calculator, then you just simply either need to use the x to the power of 3 key that will be on the calculator screen, or you can type in 7.1 times 7.1 times 7.1. It'll still give you the same answer. So 7.1 multiplied by 7.1 multiplied by 7.1 on your calculator. Very straightforward question. Just write down your answer. For the cubed root, there will be a cubed root key that will look, which can be found, just above the square root key. So just above that square root key, you'll see written in miniature that cubed root symbol. And to access this cubed root, then you'd simply need to do the shift key followed by that square root key, and the cubed root symbol will come up in the display. So then if we want the cubed root of 614.25, shift, square root, type in your number, and we can see that it's 8.5. 8.50057, but 8.5 will do. Question 7, Holly says, when you cube root a number, the answer is always smaller. Show that she is wrong. Well, if you were thinking about whole numbers, she'd actually be right. But when you start looking at fractions and decimals, this is when the rules change or the rules are reversed. So if I think of cube rooting 0.5, let's see what happens. The cubed root of 0.5 on my calculator is 0.7937. So as you can see, when we cube rooted the number, the answer was not smaller, because this one here is bigger than the 0.5 that we started with. Question 8, write down a cube number that is greater than 100 and less than 200. 5 cubed is probably the biggest one that you need to remember and would be perfect here because it's 125, which is greater than the 100 but less than the 200. Last page. Arranging these in order starting with the smallest. 2 squared is 4, 2 times 2. The cubed root of 27, how do you get 27? By doing 3 times 3 times 3. 1 cubed is with 1, and this is the square root of 25. 5 5s make 25. So starting with the smallest, 1 cubed, second smallest, cubed root of 27, third, 2 squared, and the last one, the square root of 25. Tells you here that 729 is both a square number and a cube number. Find two other numbers that are both square numbers and cube numbers. You don't have to look very far. If you go back to the beginning, 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. But now if I put next to that 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. You should know all of these. And I can see that 1 is a square number and a cube number. And I can also see that 64 is a square number and a cube number because it's in both lists. Question 11. Don says the difference between two consecutive cube numbers is always odd. Is he correct? Well, if I think about two consecutive cube numbers, they need to be next to each other when I start listing them. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6, and so on. So the difference between two consecutive cube numbers. So let's try this first two. 8 take away 1, which is 7. Yeah, that's odd. 27 take away 8 if I do the next pair. 19. Yeah, that's odd as well. And if I have a look now, I can see that there's a bit of a pattern here because we seem to go odd, even, odd, even, odd, even. So every time I'm doing one of these calculations where they are consecutive numbers, I've got an odd and an even. And whenever you have an odd and an even, or an even take away an odd, you're always going to get an odd answer. So I tested these two, and I can see that it's going to be the same as I go through any consecutive pair of cube numbers. So is Don correct? I must answer that question. Yes, he is correct.